September 1980, Northern Atlantic. American intelligence satellites detect something impossible emerging from the Soviet naval shipyard. A submarine so massive, so unprecedented, it rewrites every assumption about what submarines can be. 574 feet long, 75 feet wide, displacing 48,000 tons submerged. Heavier than a World War II battleship, 20 ballistic missiles, each carrying 10 nuclear warheads. 200 warheads, one submarine. NATO gives it a code name, Typhoon. The Soviets call it Akula, shark. And when Western analysts first see the satellite photos, the reaction is unanimous. This changes everything. Today, we're going inside the largest, most powerful, and most technologically extreme submarines ever built. Machines so advanced, they seem pulled from science fiction, operated by sailors who live underwater for months, carrying enough firepower to end civilization. This is the story of submarine gigantism, the Cold War arms race beneath the waves, and why bigger doesn't always mean better. Welcome to the world of extreme submarine technology. To understand why submarines became so massive, you need to understand what they were built to carry. In the 1950s, nuclear weapons changed naval warfare forever. Suddenly, a single submarine could carry city-destroying missiles and launch them while submerged. This created a new strategic concept, the sea-based nuclear deterrent. Unlike land-based missiles that could be targeted and destroyed, submarines could hide anywhere in the world's oceans, invisible and vulnerable. But early ballistic missile submarines had a problem. Range. The missiles could only travel a few hundred miles, forcing submarines to patrol dangerously close to enemy shores. To stay hidden, they needed to operate farther away. To reach targets from farther away, they needed bigger missiles. Bigger missiles meant bigger submarines. The arms race became a size race. America built the Ohio-class 560 feet long, 24 Trident missiles, each with a range of 7,000 miles. The Soviets responded with the Typhoon-class, even larger, designed to break through Arctic ice and launch from the safety of polar waters. These weren't just submarines. They were underwater battleships, strategic weapons platforms that redefined what naval power meant in the nuclear age, and the technology required to build them, operate them, and keep them hidden pushed engineering to absolute limits. We're talking about machines that can stay submerged for 3 months without surfacing, dive deeper than the Eiffel Tower is tall, generate enough electricity to power a small city, maintain life support for 170-plus people in a sealed environment, move silently at speeds exceeding 25 knots underwater. This is extreme technology, and it starts with extreme science. Let's start with the record holder, the Soviet Typhoon-class ballistic missile submarine. Length, 574 feet, nearly 2 football fields. Beam, 75 feet, wider than most streets. Submerged displacement, 48,000 tons. To put that in perspective, modern aircraft carriers displace around 100,000 tons, but they float on the surface. Submarines have to push through water, which is 800 times denser than air. The engineering required to move 48,000 tons silently through the ocean is staggering. The Typhoon's design is unique. It's actually 2 pressure hulls, side by side, connected by internal passages. Between the hulls, 20 massive missile tubes, each carrying an RSM-52 ballistic missile with 10 nuclear warheads. The twin-hull design provides redundancy. If one hull is damaged, the crew can seal it off and survive in the other. Only 6 Typhoons were ever built. They were hideously expensive. Each one cost more than $1 billion in the 1980s, equivalent to over $3 billion today. And they required enormous infrastructure, specialized dry docks, dedicated support ships, custom nuclear fuel. But they were terrifying. A single Typhoon could launch 200 nuclear warheads, enough to destroy every major city in the United States. And because they operated under Arctic ice, they were nearly impossible to track. America's response, the Ohio-class, slightly smaller at 560 feet but more sophisticated. Better reactor design, quieter propulsion, more accurate missiles. 18 Ohio-class submarines were built, and 14 are still in service today, the backbone of America's nuclear deterrent. Each Ohio carries 24 Trident 2 D5 missiles. Each missile carries up to 8 warheads. That's 192 nuclear warheads per submarine, able to strike targets 7,000 miles away with accuracy measured in feet, not miles. These are the largest submarines ever built specifically for war. But size brings challenges that nearly killed some of them. Building a submarine this size creates problems that don't exist in smaller boats. First, pressure. At 1,000 feet depth, every square inch of hull endures 445 pounds of pressure. A submarine the size of a Typhoon has millions of square inches of surface area. That's billions of pounds of force trying to crush the hull from every direction simultaneously. The solution? high-yield steel pressure hulls several inches thick, reinforced with internal frames every few feet. The Typhoon's twin hulls are each over 30 feet in diameter, large enough to walk through standing upright. But even with massive hulls, there are limits. Maximum diving depth for Typhoon-class is estimated at 1,300 feet. Ohio-class can go deeper, estimated at 1,600 plus feet because of better metallurgy. Second, propulsion. Moving 48,000 tons through water requires immense power. Both Typhoon and Ohio use nuclear reactors. Typhoon has two, Ohio has one exceptionally powerful reactor. These reactors generate steam that spins turbines connected to propellers the size of small houses. But here's the challenge: noise. The bigger the propeller, the more cavitation, tiny bubbles that form and collapse, creating sound that enemy sonar can detect from hundreds of miles away. So engineers designed sophisticated propeller shapes, curved blades, precise angles, materials that dampen vibration. The Ohio-class propeller is so classified that it's covered whenever the submarine is in dry dock. Taking a photo of it is a federal crime. Third, life support. 170 crew members produce enormous amounts of CO2, consume vast quantities of oxygen, and generate tons of waste. Sewage, garbage, heat. The submarine has to generate oxygen from seawater using electrolysis, scrub CO2 from the air using chemical absorbents, desalinate seawater for drinking and cooling, maintain precise temperature and humidity, store months of food without refrigeration failure, process waste without dumping anything that could be detected. It's a closed-loop ecosystem. Nothing in, nothing out, except tiny amounts of waste discharged carefully to avoid creating a detectable trail. And it all has to work flawlessly for months because surfacing means detection, and detection means mission failure or death. Living aboard the largest submarines is surreal. They're so big they have neighborhoods. The forward section, torpedo room, sonar stations, crew quarters for junior enlisted. The middle section, missile compartment, a massive multi-deck space housing the missile tubes, workshops, and some crew quarters. The aft section, reactor compartment, engineering spaces, propulsion machinery. The Ohio class has 4 decks in some sections. You can get lost. New crew members sometimes do, but size doesn't mean comfort. Submariners still sleep in racks stacked 3 high. Privacy doesn't exist. The shower schedule is strictly enforced. 3 minutes, twice a week, to conserve water. The air is always slightly metallic tasting from the CO2 scrubbers. And yet, these submarines have amenities smaller boats don't. Full kitchens with actual ovens, libraries, exercise equipment, even small lounges. The Typhoon-class reportedly had a sauna and a small swimming pool, though Western intelligence could never confirm this. Food is surprisingly good. Submarine chefs are the best in the Navy because morale depends on meals. Fresh food lasts about 3 weeks, then it's frozen in canned supplies for the rest of the patrol. The psychological challenge isn't the confinement, it's the mission. Ballistic missile submarine crews know they're carrying weapons they hope they never use. Launch orders mean nuclear war has started. Civilization is ending, and they're launching the missiles that will finish it. That knowledge weighs on you. Every drill, every training exercise, you practice the procedures for ending the world. Some crew members describe it as living inside a loaded gun, quiet waiting, hoping you're never fired. But you train constantly because if the order comes, hesitation isn't an option. The 2-person key system, the authentication codes, the launch sequences, everything is designed to ensure that when commanded, the missiles fly. No questions, no delays. Just follow orders and hope you're never given them. Size creates vulnerabilities. The larger the submarine, the more that can go wrong, and the harder it is to save. August 12th, 2000. The Russian Oscar II-class submarine Kursk, one of the largest attack submarines ever built at 508 feet, is conducting torpedo exercises in the Barents Sea. At 11:28 a.m., a torpedo misfires. Hydrogen peroxide fuel explodes inside the torpedo tube. The blast kills everyone in the forward compartment instantly. Secondary explosions follow. The submarine, massive and damaged, sinks to the seafloor at 354 feet, but 23 sailors survive in the aft compartments, sealed behind watertight doors. They write letters to their families. They bang on the hull. They wait for rescue. Russian naval authorities know the submarine is down. They know men are alive, but pride, bureaucracy, and equipment failures delay international rescue efforts. By the time rescue ships arrive, it's too late. The sailors lasted 18 hours in the darkness before the air ran out. Size made rescue harder. The Kursk was too large for standard rescue equipment. Docking a rescue vehicle required precise positioning. difficult on a submarine lying at a steep angle on the seafloor. The sheer mass of the boat, over 24,000 tons submerged, made any salvage attempt extraordinarily complex. The entire submarine was eventually raised in 2001, one of the largest and most expensive salvage operations in history. But the men were already gone. Even the mighty Typhoon-class wasn't invincible. Several experienced serious accidents during Cold War patrols, reactor incidents, equipment failures, near collisions with American submarines tracking them. Most incidents remain classified, but enough has leaked to confirm size doesn't guarantee safety. In fact, larger submarines are easier to detect acoustically despite better sound dampening. They displace more water, create larger pressure wakes, and generate more reactor noise. Modern anti-submarine warfare focuses on detecting these giant boats, specifically because finding them means finding the enemy's nuclear deterrent. The era of submarine gigantism is ending. Modern naval doctrine favors smaller, more versatile submarines. America's Virginia-class attack submarines are 377 feet long, massive by historical standards, but dwarfed by ballistic missile boats. Yet they're faster, quieter, more maneuverable, and far more adaptable. Why? Because technology has miniaturized. Modern missiles are smaller but more powerful. Computers and sensors that once filled entire compartments now fit in server racks. Nuclear reactors are more efficient, requiring less shielding in space. The future belongs to unmanned underwater vehicles and AI-controlled autonomous submarines. These can be smaller, stay submerged indefinitely, and operate without risking human lives. Several navies are already testing large unmanned submarines capable of carrying conventional weapons or deploying sensors. China is reportedly developing a massive nuclear-powered autonomous submarine, a drone larger than most manned attack submarines. Russia claims to have built the Scariest Poseidon, an unmanned nuclear-powered torpedo the size of a bus, capable of carrying a 100-megaton warhead across oceans autonomously. These systems are controversial, potentially destabilizing, and represent the next revolution. Submarines don't need crews, don't surface, and patrol for years without human intervention. But for now, the Ohio-class and its equivalents remain the ultimate expression of submarine gigantism. Floating cities armed with civilization-ending weapons, operated by sailors who live in darkness and hope their missiles rust away unused. They are engineering marvels and strategic nightmares, symbols of human ingenuity and human folly. And somewhere beneath the waves, right now, they're out there, watching, waiting, silent. The legacy of extreme submarine technology isn't just military. It's transformed how humanity relates to the ocean. Everything we know about deep survival, closed loop, life support, long-duration underwater operations came from building and operating these giants. NASA studied submarine environmental systems when designing the International Space Station. Deep-sea research universities use technologies pioneered in military submarines. But the strategic impact is profound. Ballistic missile submarines remain the most credible nuclear deterrent. They're invulnerable to first strikes, can't be easily tracked, and guarantee retaliation. This has prevented nuclear war for 80 years. Not because nations don't want war, but because submarines make winning impossible. The doctrine is called mutually assured destruction. It's dark, it's terrifying, and it works precisely because submarines like the Ohio and Typhoon exist. Economically, these submarines are staggering investments. Each Ohio-class cost over $2 billion to build, and hundreds of millions more per year to operate. Russia couldn't afford to maintain the Typhoon fleet after the Cold War ended. All 6 have been decommissioned, with 1 preserved as a museum. The United States plans to replace the Ohio-class with the new Columbia-class, starting in 2031. Even larger, even more expensive, and designed to patrol until 2085. Each Columbia will cost over $8 billion. That's $100+ billion for 12 submarines, more than the GDP of many countries. But naval strategists insist there's no alternative without ballistic missile submarines. Nuclear deterrence collapses. The sailors observe aboard the experience is life-changing. Many describe it as the hardest thing they've ever done, and the most meaningful. They were entrusted with unimaginable destructive power and chose never to use it. That's the paradox. These submarines exist to prevent their own purpose. Their weapons designed never to be fired, operated by people who hope they never receive the order. For 80 years, they haven't, not once. So what makes a submarine extreme? It's not just size, though the Typhoon-class remains the largest submarine ever built, a record that may never be broken. It's not just firepower, though a single Ohio class carries more destructive power than all bombs dropped in World War II combined. It's the audacity of the concept of building machines the size of office buildings, sealing them underwater for months, operating them in total silence, and trusting human beings to live inside them without ever seeing sunlight, all while carrying weapons they hope to use. These submarines represent the pinnacle of human engineering and the depth of human fear. They exist because we built weapons that can end civilization, and realized we needed ways to prevent anyone from using them. The solution was hiding those weapons where no one could find them, beneath the waves, in darkness, operated by volunteers who accept the psychological burden of being civilization's last line of defense. Right now, at this very moment, ballistic missile submarines from multiple nations are patrolling. American Ohio-class boats in the Pacific and Atlantic, British Vanguard-class in the North Atlantic, French Triomphant-class in the Mediterranean, Russian Boré-class under Arctic ice, Chinese Jin-class in the South China Sea. No one knows exactly where they are. Not even their own governments track them continuously. That would risk compromising their positions. They are ghosts in the deep, cities beneath the waves, guardians of peace, through the promise of annihilation. Crews aboard these submarines live with the burden most of us can't imagine, knowing that if they ever launch their missiles, the world above has already ended. Their mission is deterrence, existing as a threat that prevents war. And for 80 years, they've succeeded. These are the largest, most powerful, most technologically extreme submarines ever built. They are marvels of engineering. They are instruments of mass destruction. They are, paradoxically, the reason nuclear war hasn't happened. If you want to see more about submarine technology, check out our documentary on the deepest diving submarines ever built. Machines that descended to depths that would crush these giants instantly. Link on screen. Thanks for watching. And remember, somewhere beneath your feet, possibly at this very moment, one of these submarines is passing by. Silent, hidden, watching,